What biologists are coming to see now is that there's a series of transitions over evolutionary history, genes coming together on chromosomes, simple what are called prokaryotic cells coming together to form more complicated eukaryotic cells with subunits, single cells coming together from multicellular organisms, individuals coming together to form social or eusocial organisms. And here's the bottom line. With each of these major evolutionary transitions, which involve kind of an increased scale of obligate interdependence, on the one hand, you have the loss of autonomy of the previously individual and freely existing entities. But on the other hand, you have the increase of biotic function. So you have organisms being able to do things that they couldn't do before, or do things better. An example would be the light-sensitive spot in a single-cell organism. As multiple cells come together, you have the emergence of complex eyes, which have degrees of resolution and responsiveness to the natural environment, which would be impossible without this coming together. Or you have the capacity to control internal conditions, control temperature, for example, which single-celled animals can't do. And the reason I find this, along with many of my colleagues, so fascinating is that over the history of life, you actually have a progressive increase in what one might call review as the very capacities of life itself. And that this is made possible by a sequential series of steps of greater cooperative interdependence. So it turns out that cooperation is not only an end product of evolution, but in a sense it can also be viewed as an enabler or a driving force behind the evolutionary emergence of biotic capacities.